Okay, so number 7. This is number 7 on the chapter 3 HL review. It gives us a curve y equals x squared minus 5. And it looks somewhat like this, right? Here's our quadratic formula. Oops, to make it look better. Alright, so this is the minimum right here, and it crosses negative 5. That's our y-intercept negative 5. This is just x squared. So a point P on the curve has x coordinate equal to a. I'm just going to draw my own point P. I'm going to pretend this is point P. It wasn't drawn on the graph originally, but I drew it myself. So it has x coordinate of a. Okay. Part A. It asks us to to show that a distance OP equals a to the fourth power minus 9a squared plus 25 and the root of all that. Alright, so our origin is here, OP. This is OP, right? So here's our triangle that I just drew. This is O, this is P, this is a distance of A. We want to find this distance, OP, right? And we know this distance. How do we know this distance? Well, to find the y value, right, this is our y value here. All we need to do is plug in the A value into x to find our y value at P. So this would be our y value equals a squared minus 5. Okay? Alright, so this is a right triangle right here, which means OP is a hypotenuse. So OP squared equals a squared plus our y value a squared minus 5 squared. Alright, that equals a squared plus a to the fourth power minus 2a squared plus 25. Yes? That's OP squared. So to find just OP, that equals the root of a squared plus a to the fourth power minus 2a squared plus 25. Oh, I'm sorry. This is not 2a squared. This is 10a squared. My bad. Okay, so what you got makes it equal to a to the fourth power minus 9a squared plus 25, which is our distance from our point to the origin, proving what we'll try to solve in part A. Okay, part B. Part B says, find the values of A for which the curve is closest to the origin. Well, we know that, let's write this down again. OP equals a to the power minus 9a squared plus 25. We want this to be as small as possible, right? So we can rewrite this as a to the fourth power minus 9a squared plus 25 to the negative, to the 1/2 power. That's square root. Okay. Alright, so to find it closest to origin, which means that we want to find the minimum value of this equation, right? So to find the minimum value of this equation, we know that at a minimum, let's say this, at a minimum, our tangent to that point would equal 0. Or the slope of our tangent line equals 0, which means the derivative of this must equal 0. Let's first find the derivative. Okay. Let's pretend this is f of a, alright? And let f of a equal g of h of a, okay? Where g of a equals a to the 1/2 power, and h of a equals a to the fourth minus 9a squared plus 25. So the derivative of f of a equals the derivative of g of h of a times the derivative of h of a. Now, that would equal the derivative of g of h of a equals, well, we move down 1/2 over here, of a, h of a, to 1/2 minus 1/2, or 1/2 minus 1, which is negative 1/2, times the derivative of h of a, which equals to, no, 4a to the cubed minus 9 times 2, 18a plus 0. Okay. This equals the, well, this equals all of that over 2, right? 1 over 2. And this negative 1 over 2 means okay, so negative brings it down to the bottom, and 1 over 2 is separate. So a minus 9a squared plus 20. Right? And alright, we want this to equal 0, right? Our derivative. So our derivative equals that. Well, when we multiply the denominator with 0, we still get 0. So our derivative, or 0 equals 4a cubed minus 18a, right? So 4a cubed, 0 equals, let's take out 2a squared minus 9. Okay, so a can equal 0, or 2a squared minus 9 equals 0. A squared equals 9 over 2. A equals 3 root over root 2 plus minus 3 root 2, which equals 3 root 2 over 2. This is our answer. This is what A can equal. And that concludes number 7.